Jastrow illusion. Can you tell which curve is smaller or bigger? If you said the green one's smaller or the red one's bigger, your eyes are tricking you. They're actually the same. Curves can really mess with your eyes. This cool illusion was discovered way back in 1889 by a psychologist named Joseph Jastrow. Ebbinghaus illusion. Guess which inner circle looks smaller or bigger. If you said the one on the left is smaller or the one on the right is bigger, you're wrong. They're actually the same size. That's because the size of the surrounding shapes affects how we see things. This visual trick was discovered by Hermann Ebbinghaus in 1901. Poggendorf illusion. Look at this illusion. Does it seem like the black line on the left connects to the blue line on the right? If you said yes, you're wrong. The black line actually lines up with the yellow one. Your brain is being tricked by how it sees depth and space. The more vertical the line and the wider the gap, the stronger the illusion looks. The Munker-White illusion. Look at the red boxes on the left. They look lighter than the ones on the right, right? Nope. They're actually all the same color. Don't believe it? Look again. Crazy, huh? This is called the Munker-White illusion. The black and white stripes trick your brain into seeing different shades, even though the color hasn't changed at all. Shepherd tables. Can you guess which table is longer and skinnier? If you said the red one, wrong. The blue one? Also wrong. They're actually the exact same size and shape. Don't believe it? Take a closer look. Crazy, right? This is called the Shepherd's tables illusion. Roger Shepard created it to show how our brains automatically try to turn 2D images into 3D, even when it totally messes with what we see. Ponzo illusion. Guess which line looks longer, the top one or the bottom one? If you said the top, you're wrong. They're actually the same size. Don't believe it? Look again. This illusion works because of the background. Those angled lines make it look like the top rectangle is farther away, so your brain thinks it must be bigger. This trick was first shown by Mario Ponzo in 1913. Stepping feet illusion. Which box looks like it's moving faster? The yellow one or the blue one? If you said the blue one, you're wrong. They're actually moving at the same speed. Don't believe it? Watch again. When the blue box moves over the white stripes, the contrast is strong, so it looks like it's going faster. But when it moves over the black stripes, the contrast is weaker, so it seems slower. It's just your brain getting tricked by the colors. And guess what? The opposite happens with the yellow box. It looks slower on white and faster on black. Herring illusion. Look at the red line. Does it look curved? Many people say yes, but it's actually a straight line. So, why does it look like it's bending? This is an optical illusion. The red line crosses over blue lines that spread out like rays. Our brain sees those crossing points and thinks the angles are bigger than they really are. This tricks us into seeing the red line as curved, even though it's perfectly straight. This illusion was first noticed by Ewald Hering in 1861. Skipping pylon. Watch this video. Do you hear a thud or bounce sound when the pylon hits the ground? If you do, you're not actually hearing a real sound. There is no sound in the video at all. Some people say they hear a thudding or boing sound, but that's just your brain imagining it. Your brain expects to hear something when it sees the pylon bounce, so it fills in the sound on its own. Troxler effect. Watch this. Keep staring at the small X in the middle for 10 to 15 seconds. Did you notice something? Does the cat seem to slowly fade away? Well, it doesn't actually fade. It's a trick your eyes play on you. When you stare at one spot for a while, the parts of the image in your side vision, peripheral vision, start to disappear. That's why the cat seems to vanish. And often the grin is the last thing you see, leaving just the black X in the center. Impossible trident. Look at the left end of the shape. It looks like the fork has 3 prongs, right? But now look at the right end. It only shows 2 prongs. That doesn't make sense. Your eyes see something that looks real, but your brain knows it's not possible. This is an example of an optical illusion that tricks your brain into seeing something that can't actually exist. Hermann grid. Look at the grid. Do you see dark spots where the white lines cross? Surprise! Those dark blobs aren't really there. Your eyes are being tricked. This happens because of how special cells in your eyes, called retinal ganglion cells, react to light. These cells send signals to your brain. At the intersections, they get less light overall, so your brain fills in the gap with a dark spot, scintillating starburst. Look closely. Do you see a bright ray? There's actually no ray in the image at all. What you're seeing is an illusion made from layered shapes, called concentric polygons. These shapes form wreath-like patterns, and where the corners of each layer meet, your brain sees bright spots. Since those are the thinnest parts, your brain fills in the gaps and draws imaginary rays between them. It's just your mind making sense of the pattern. Rotating snakes. Look at the image. Does it look like it's spinning? Now try staring at one spot. It stops moving, right? Here's the crazy part. The image isn't moving at all. It's just a trick your brain is playing on you. The pattern in the image makes your brain think there's motion, even though nothing is actually moving. This happens because the shapes and colors mess with the way your brain usually sees real movement. Cafe wall. Look at this wall. Do the horizontal lines look like they're bending in different directions? If you said yes, your brain is tricking you. The lines are actually straight and perfectly parallel. Scientists still aren't totally sure why this illusion works so well, but it seems to have something to do with how our brain cells handle angles and shapes in the part of the brain that helps us see. Hybrid image illusion. Look at this image. What do you see? If you saw Albert Einstein, you're totally right. And if you saw Marilyn Monroe, you're also right. How is that possible? It's a special trick called a hybrid image illusion. What you see changes depending on how close or far you are from the picture. When you're up close, you'll most likely see Einstein. But if you step back or shrink the image, you'll start to see Marilyn Monroe instead. Confetti spheres 5. Look at the image. How many different colors do you think the spheres are? If you said 3, you're wrong. All the spheres are actually the same color, a light beige. Hard to believe? Look closely. The stripes going across the spheres trick your eyes. Our brain sees shapes better than colors, so the colors of the stripes mix into how we see the spheres. That makes them look like they're different colors, even though they're not.